All right. So we'll finish up 5-7 today. Next week, no, we're not finishing up 5-7. We're gonna finish up 5-7 on Monday with the snow day now, because of the snow day. We'll do a test review, test Thursday of next week. All right. Then we'll get into chapter 6. So the chapter 5 test Thursday of next week. No questions on the homework? Doing okay, Kelsey?
Can you go over 16?
Sure. All right, find the inverse and graph. Which part was it? Finding the inverse or graphing?
Finding the inverse.
Okay. So we're going to switch x and y. You guys all right? All right, did you subtract 1/5 first? So we have x minus 1/5 equals negative 4/5 y. What'd you do next?
I times by negative 5/4.
Good. Hey guys, quiet down a minute, please. So we know those are going to cancel. I'm going to switch them around. So we have y equals negative 5/4 times x minus 1/5. Did you distribute then, or did you forget parentheses?
No, I just typed it into my calculator with like parentheses and all, and then it gave me negative 5/4x plus 1/4. But it said that like there was a different answer.
Plus 1/4? Plus 5 over... Yeah, so I mean, if you multiply those out, you get positive 5/20, which is 1/4. So we call that the inverse function. Inverse of x equals negative 5/4 x plus 1/4. Maybe you might have missed it. Did you hear me say if you divided those in there, you'd have negative 5/4 x plus 1/4? If you divide, are you with me?
Yeah. Okay.
Do you guys all? That's important moving forward. You guys understand how to manipulate this to make it look like, just fractions and no denominator, like two separate fractions? Comfortable with that? Not really. Do you understand when to do it, when not to do it? Good talk. All right. Do you want me to explain that?
No.
Okay.
Yeah.
Sure. Your head says in. You're okay.
Yes.
You guys okay? Okay. Kelsey, do you understand? Does that make sense now? You want me to show you? I can show you another. If you pull, do you agree I could pull a negative 1/4 out?
Mm-hmm.
Like to move that negative 4 is in the denominator. If I pulled a negative 1/4 out and distribute it, I get negative 5/4 x, and then the negative 1/4 times negative 1 would be positive 1/4. So those are all acceptable answers. Yours is fine. It's getting pretty aggressive over there. All right, where are we? Today, we are doing inverses of nonlinear. Now is where it gets exciting. All right, I need you guys to pay very close attention to this. This is going to be around for the next few years. The inverse of y equals x squared is x equals y squared. I bet that's not too much of a stretch for you to imagine. This is where I've been making a big deal out of it all year, or y squared equals x. Okay, red. I'm going to try to stay consistent. Red, inverse function, yes? I've already switched x and y. I just rewrote it in order just because I like to write y's first. How would I solve that? What would I do to both sides to get y by itself or the inverse by itself? Square root, right? When I take the square root of both sides, I have to allow for a plus or minus. Now look what happens. If I were to graph the positive square root of x, haven't we done that already a few sections ago? There's the positive square root of x. But isn't the negative square root of x the reflection of that across the x-axis? You see it? So it's actually both. It's both parts. The inverse function is both parts. Which makes sense because if I were to reflect that across the line y equals x, I have to have the bottom part too. Here's the problem. Does this inverse function pass the vertical line test? No. Do you remember the vertical line test? It's a test whether you have a graph that's a function or not. Passes the vertical line test, it's a function. Fails the vertical line test, not a function. And the vertical line test is if you draw any vertical line, if it hits the graph twice, not a function, meaning there's two outputs for one x, for one input. Can't have that if it's going to be a function. Now let's look at the x cubed graph. Can you guys all see the blue x cubed graph? The inverse is the cube root of x. Okay? It's that reflection across the line y equals x. It's the cube root of x. And I bet you could see why it's the cube root of x. If you switch x and y and you solve, you have to take the cube root of both sides, don't you? All right. Now, back up, blue graph, eyes on the blue graph. What's the domain? All real. What's its range? Y is greater than or equal to 0. So, blue graph, original. Domain? All real. Range? Y is greater than or equal to 0. Ready? Red graph. Domain? X is greater than or equal to 0. Range? All real. See how the domains and ranges have switched? Okay, the domain and ranges have switched. So be careful there whenever you take the inverse. Domains and ranges switch. All right. All right, what else did they say? When the domain of f of x equals x squared is restricted to only non-negative real numbers, the inverse of f is a function, as shown in the next example. Now, what does that mean? If you only pretend like the one part of the graph of the original exists, then when you find the inverse, it can now pass the vertical line test, okay, if you want to keep it a function. All right, find the inverse of the function, then graph the function and its inverse. Now, I've already kind of done the warm-up problem to get you guys thinking about this. Do you agree x squared would normally look like this? 0, 0, it would go up to the left, up to the right. What are they doing though? They're restricting it. X is greater than or equal to 0. So we can't see to the left of the y-axis. We're only graphing it to the right of the y-axis. So let's go ahead and graph this one together. 0, 0, 1, 1, 2, 4, 3, 9. That's f of x equals x squared on the what's called the restricted domain. So what's the inverse? X equals y squared, square root, y equals plus or minus the square root of x. So f inverse of x is plus or minus the square root of x. But what's the problem with this? We solved it correctly. What do we have to adjust on the red function? Okay, back up. What was the domain of our original? X is greater than or equal to 0. Right, that's the domain. They restricted it for us, didn't they? They said only graph it for x is greater than or equal to 0. That means the range of this needs to be. So don't the y's need to be greater than or equal to 0? So which part of that do I need to adjust? Come on, you got this. Huh?
Give us a hint.
You want a hint? Yeah. So if the blue graph, I'm only allowed to graph x's 0 and to the right because they told me to. Then on the red graph, I'm only allowed to graph y values. Fill in the blank.
Greater than
Or equal to 0, right?
Yeah.
Let's plug in a table of values and see if you guys see the issue here. X, f inverse of x. Ready? When x is 0, what's the square root of 0? 0. Positive or negative 0? Okay, whatever. Positive 0, 0, negative 0, 0. It's just 0 either way. Plug in x equals 1. What's the square root of 1? Times a plus or minus. What should it be? 0, 0, okay. Positive 1 for x. What's the output? Plus or minus 1, right? Can that happen? I'm going to don't graph this for a second. 1, 1, 1, negative 1. That's what that told me. Don't write this down. Do you agree? I plugged in 1. I got out positive 1 and negative 1. Are you with me? What's the problem? Can't have that. Why not? Y has to be greater than or equal to 0. Why? Because the domain was x is greater than or equal to 0. So my inverse, y has to be greater than or equal to 0. So this negative part, I'm going to cross it out. It's not allowed, right? Mathematically, it was correct, but when I go to apply it to this problem, I have to restrict it. So I'm only graphing, I'm going to erase this. I'm only graphing 1, 1. I'm not graphing 1, negative 1. Let's keep going. Pick strategic points. I'm not going to pick 2. I'm not going to pick 3. 4. What's the square root of 4? 2. Plus or minus 2? Or just 2? 2. And now you can probably see why earlier in the year I made such a big deal out of, is it plus or minus, or is it just the positive square root, right? I didn't want you guys to get confused later on. It's possible it's either one, but you have to look at the context of the problem. So I'm going to graph the point 4, 2. I'm not going to plug in 5, 6, 7, 8. Now I'm going to plug in 9, 9, 3. Does that look like an accurate inverse function? Yeah. If it was like this, don't graph this. If it was like that, it wouldn't look accurate, would it? All right, next one. I bet everybody could look at this graph and say that's a parabola that's been shifted down 2. Vertex is now at 0, negative 2, right? But its vertex is still on the y-axis, so we're only going to graph x is greater than or equal to 0. So I'm going to graph the point 0, negative 2. If you need a table of values, that's fine. X, f of x, 0, negative 2. 1, what's 1 going to be? I wrote, that was stupid. 0, 0. 1. Oh my gosh. Don't try to talk and do things at the same time. All right. 0, negative 2. Backing up. I get a redo. I'm taking my redo right now. 0, negative 2. 1, negative 1. By the way, if you realized we just graphed x squared and you knew it was 0, 0, 1, 1, 2, 4, 3, 9, don't all of these ones shift down to you from what we just did? Yeah. You can do that too. All right. 2 squared is 4 minus 2. 2, 2. 3, 7. That's enough to graph that one. All right, what about the inverse? Well, the inverse, we have x equals y squared minus 2. Add 2. Square root, square root. When we take the square root, we have to allow for a plus or minus. But to keep it a function, we're going to get rid of the negative part, just like we did in the last one. All right, table of values. By the way, I like to kind of wrap it up by saying each problem by saying not y, but f inverse of x. And so xy, or x comma f inverse of x. How do I know where I'm allowed to start plugging in values? Right?
When the x is greater than or equal to 0.
The inside is greater than or equal to 0, right?
Yeah.
What will cause? What's the first output I can plug in? Sarah?
-2.
-2. Agree? -2. If I plug in -2, what do I get?
0.
-2 plus 2 is 0. Square root of 0 is 0. So -2, 0. Now, could we cheat a little bit and peek at the table of values up here and switch them, graph all those? Right? I mean, couldn't we? Let's pretend we didn't. What's the next value I could plug in that would make sense to get a nice square root? 2, when x is 2. 2 plus 2 is 4, square root of 4 is 2. So 2, 2. Gosh. I said 2, right? 2 plus 2 is 4, square root of 4 is 2. 2, 2. 2. 2. What's the next nice square root? X when x is 7. 7 plus 2 is 9. Square root of 9 is 3. 7, 3. And that's enough to see that's going to happen there. We could have graphed -1, couldn't we? I mean, if I plugged in -1 plus 2 is +1, square root of 1 is 1. We could have graphed that. So yeah, you can, if you're confident with your table of values, you could graph x's and y's switched for the inverse table of values. Does that look? Can you guys see the symmetry on that one? The line y equals x symmetry on that one? Hopefully. All right, you can use the graph of the function to determine whether the inverse of f is a function. All right, this is what we're getting after. I bet this doesn't take you guys much. I tried to introduce it in a way that hopefully makes sense now. Have you ever heard of the horizontal line test? The answer is no. Okay. You've never heard of what's called the horizontal line test. Vertical line test? How many of you had heard that before today? Right? Vertical line test tests for whether it's a function. Tell me if this makes sense. Pretend this red graph isn't here. Pretend this red graph is not there. Finish my statement. If the original function passes the horizontal line test, then the inverse function will pass the vertical line test. True or false? If the original function fails the horizontal line test, like this one, then the inverse function will fail the vertical line test. Do you agree with that? Say it one more time. If the original function fails the horizontal line test. It failed it. It hit it twice. I drew a horizontal line. It hit it twice. Then the inverse function will fail the vertical line test. Okay? That's what this is saying right here. Do we see how x cubed passes the horizontal line test? So its inverse will pass the vertical line test. The y equals x squared graph fails it. That's why they've restricted the domain on those couple of example problems we did. All right, therefore its inverse will fail the vertical line test. All right, find the inverse of the function, then graph the function in its inverse. All right. So find the inverse. Inverse. X equals 2y cubed plus 1. X minus 1 equals 2y cubed. Divide by 2. Divide by 2. Y cubed equals x minus 1 over 2. Now, I'm tempted to write that a different way too. Couldn't I write that? We talked about this when Kelsey asked about the homework question. We could write this one as 1/2 x minus 1/2, right? 1/2 x minus 1/2. I'm just a little nervous that when I plug in x values for a table of values, that those might get messy. Like, okay, 1/2 times 3 minus 1/2. 1/2 times 2 minus 1/2. It might be nicer to leave it like this. We can kind of adjust if we need to. But to solve, I'm going to take the cube root of both sides. So the inverse function, now that it's solved, is the cube root of x minus 1 over 2. All right, let's graph the original. It said find the inverse, graph the function and its inverse. So for this one, we have x, f of x. 0, we have 1. Let's graph some negatives as well. Sorry, let's graph some negatives. Let's do, that's going to get it's going to get very low very fast. If we plugged in -2 cubed is -8, might get kind of, let's start with -1. I think we'll be able to see what it's going to look like with -1, 0, and 1. All right, -1 cubed is -1, times 2 is -2, -2 plus 1 is -1. So -1, -1 is a point on the graph. What's the next point? 0, comma, 1. And do you guys remember what the x cubed graph looks like? This one? Yeah. So use your context with this problem. Isn't it going to be stretched by a factor of 2, then shifted up 1? So that turning point that's usually at 0, 0 is now at 0, 1. So we just graphed 0, 1. That's that turning point. Let's plug in 1. 1 cubed is 1, times 2 is 2, plus 1 is 3. 1, 2, 3. So that one, I know it's kind of tough to piece together, but that's going to be hard. It's going to go up and then curve up like that. That's the original. What's the domain of that function? All real? Range? All real, right? What about the inverse function? Let's see. X, f inverse of x. Now, we know we could use the blue table of values and swap them out, right? So let's kind of peek. Let's peek. If a point on the original was negative 1, 1, then isn't a point on the inverse going to be negative 1, 1? Let's try it. Let's plug in negative 1 for x. Negative 1 minus 1. Negative 2 divided by 2. Negative 1. And the cube root of negative 1 is negative 1. So negative 1 was a point on the graph. Negative 1, negative 1. Let's peek at the next value we found. If 0, 1 was a point on the original, then 1, 0. Let's plug in 1 and make sure. 1 minus 1 is 0. Divided by 2 is still 0. And the cube root of 0 is 0. So 1, 0 is a point on the graph. I'll give you another little hint. I called it the turning point. We don't really know what to call this point yet right here. The turning point on the blue graph is going to correspond with the turning point on the inverse graph, okay? Just so you know. Well, that was at 0, 1. So at 1, 0, we kind of anticipate this is going to start turning now. If 1, 3 was a point on the original, then 3, 1 should be a point on the inverse. Let's test it. What's 3 minus 1? 2 over 2. 1. Cube root of 1. 1. Can we kind of see it's going to go like this? All right, what if you wanted more? What if you wanted to graph more points? You should be thinking to yourself, what in here will give me a cube root of a number that I know? Well, I know the cube root of 8. I know the cube root of 27. Right? Are there numbers I can plug in there for x that will give me those values? 17? What's 17 minus 1? Divide by 2.
8.
Cube root of 8? 2. What did you plug in, Charlie?
17.
And you got 17, 2. Now, we can't see out to x equals 17, but if we could, yep, it'd be up to 2. So mine, I got up to a height of 2 a little bit too early, okay, which is fine. This is just a sketch of it, okay? What does that mean would be a point on the original? 217. Let's go back to the original. 2, what's 2 cubed? 8 times 2 plus 1, 17. Are you guys understanding the relationship there? Okay, back up. Does the blue graph, eyes up here, does the blue graph pass the vertical line test? Yeah. So the blue graph's a function. Is the red graph a function? Yeah. Back up. To test if the red graph is a function, does the blue graph pass the horizontal line test? One more time. Does the blue graph pass the horizontal line test? Yeah. So then the red graph must be a function, yes? All right, next one. Ooh, this is our last one. Describe this graph to me. It's a square root graph. Vertical stretch by a factor of 2, translated to the right 3. Yes? What's its domain going to be?
Real numbers greater than or equal to 3.
That's like in baseball, like a pinch hitter just walks in and just like clutch hit right there. Well done. X is greater than or equal to 3, right? Now, we're going to graph this. But do you guys think you're going to get, you know how the square root graph looks like this? Like this? Yes? Is it going to also, are we also going to graph the bottom part of it?
No.
No, why not?
Because it's not greater than
Say it again.
Because it's not greater than 30. Or I don't know.
Well, what would cause that bottom portion of the graph to be there? What caused the bottom portion of the graph to be there?
Oh, X is negative.
The positive or negative square root of x, yes? Do you see a plus or minus here?
No.
So all you're going to graph, I mean, you don't need to worry about it right now, but only expect to see the positive portion of it, okay? All right, so 3, 3, 0 is our first point on that graph. You try to plug in a value less than 3, you're going to get an imaginary solution. Well, I'm not going to plug in 4. Well, yeah, I'll plug in 4. 4 minus 3 is 1. Square root of 1 is 1 times 2 is 2. 4, 2. 4, 2. Not going to plug in 5. Not going to plug in 6. What about 7? 7? 7 minus 3 is 4. Square root of 4 is 2. Times 2 is 4. That's about what we expected, right? We know what the square root of x graph looks like. It's been vertically stretched by a factor of 2 and then shifted to the right 2. Makes sense, right? What about the inverse? Well, the inverse. We've got x equals 2 radical y minus 3. Divide by 2. Square both sides. Add 3. Ooh, let's not be backing up yet. Isn't that 1/4 x squared plus 3? I got a problem with that. You have a problem with that? What's the domain of the original? X is greater than or equal to 3? Yes? What's the range? Y is good. If I walked in today and I gave you this problem, domain. If just you looked at this problem, domain. All real. Uh-oh. Problem. Why? Didn't the original have a restricted? Told me? All right, we're going to have to restrict this one. So we're only going to graph which side of it. Do you agree that the right side of it? Yes? So x squared over 4 plus 3. What's the first value I'm allowed to plug in? What's the first x value I'm allowed to plug in? 0. Why? Look up here, guys. I'm trying to help you. I know this is complex. If the range was y is greater than or equal to 0 on the original, isn't the domain on the inverse going to be x is greater than or equal to 0? Better write that. First value I'm allowed to plug in, 0. When I do, I get 3. 0, 3. Let's peek a little bit at the table of values. If 4, 2 is a point, then 2, 4 is a point, right? Let's double check. 2 squared is 4 over 4 is 1. Plus 3 is 4. Awesome. 2, 4. 1, 2. 4. Next one on the original, I had 7, 4. So 4, 7. Let's double check. 4 squared is 16 over 4 is 4. Plus 3 is 7. 4, 7. And there you go. It's just that right side of the parabola. Do you understand that? All right. Please, if it asks you to graph, please graph it on graph paper. How many of you guys are going on the ski club trip? Have fun.